Step into the Colosseum of Cambridge exams. Only the prepared survive. Welcome to this Exam Strategy Explainer, where we take complex concepts and make them instantly clear. Today, we're diving into the absolute magic of mathematics, graph transformations. We're going to look at how you can instantly map and manipulate complex exponential graphs without having to painstakingly plot them point by point. Honestly, it's like learning the cheat codes to the coordinate plane, and it is a massive time saver for paper 5080. Here's our battle plan for today. We'll start by meeting the exponential curves, then discover the invisible boundary known as asymptotes. After that, we'll introduce graph transformations, specifically looking at vertical shifts moving up and down and horizontal shifts moving left and right. We'll wrap it all up with the ultimate translation vector cheat sheet. Section 1. Let's meet our exponential curves. To truly master transformations and grab those top marks, we first need to get intimately familiar with our core characters. Take a look at that rapid upward sweep for the function f of x equals 2 to the power of x. This classic hockey stick growth curve is exactly what you're going to see whenever your base value, that a, is a number greater than 1. As x increases, y literally shoots up exponentially. It starts slow and then just skyrockets. But conversely, watch what happens when our base value is a fraction. When that a is between 0 and 1, like in the function f of x equals 1/2 to the power of x, the story completely flips. You see this distinct decay curve sloping downwards. As we move from left to right, the values just get smaller and smaller, dropping super rapidly before they start to level out at the bottom.
Now, what's really fascinating here is how we can see multiple variations at once. Whether it's growth or decay, varying that base value, say bumping it from 2 to 3 to 4, dramatically changes the steepness of the curve. Higher bases give you much steeper climbs or steeper drops. Yet, and this is the crucial part, despite these differences in steepness, the overall family shape of the exponential curve remains totally anchored and recognizable. Section 2. Let's talk about the invisible boundary, asymptotes. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the math. So, did you notice how those curves we just looked at seemed to flatten out at the bottom, but never quite disappeared? That flattening behavior is caused by something called an asymptote. Think of an asymptote as an invisible mathematical force field. It's literally a line that a curve gets infinitely close to as it heads towards infinity, but no matter what, it will never, ever actually touch or cross it. For our basic exponential graphs, the x-axis acts as this rigid boundary. The real question the examiners want you to understand is why this happens. Let's break it down. For f of x equals 2 to the power of x, as x moves towards negative infinity, the function approaches 0. Why? Well, applying the laws of indices, 2 to the power of negative x is the exact same thing as 1/2 to the power of x. And think about it. Taking half of a half of a half forever gets you incredibly close to 0, but you'll never actually reach absolute 0. That mathematical reality is what creates that horizontal asymptote right on the x-axis. Moving on to Section 3, Introduction to Graph Transformations. Now that we know our base shapes and their invisible force fields, let's learn how to actually pick these shapes up and move them around the coordinate plane. The core definition is this. When a function undergoes a transformation, the shape or position of its graph changes. Why does this matter? Because it's a massive exam time saver. It means once you know the shape of a starting function, you never have to blindly plot it from scratch again. You just apply the transformation rules to the base shape, and boom, you're done. Section 4. Vertical shifts. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's start with the most intuitive movement of all, sliding our entire graph straight up or straight down on the y-axis. The rule here is wonderfully straightforward. If a constant k acts externally to the original function, meaning it's just tacked onto the very end, like a +2 or a -3, it creates a direct vertical translation. A positive k moves the whole shape up, and a negative k moves it down. The shape itself doesn't stretch or warp at all, it literally just relocates. This step-by-step example brilliantly illustrates the concept in action.
Look at how every single coordinate responds to the transformation y equals f of x plus 2. We start by identifying our original points. A is at 0, 0, B is at 2, 1, and C is at 3, 0. By applying that external plus 2 vertically, we simply add 2 to every single y coordinate. So A becomes 0, 2, B becomes 2, 3, C becomes 3, 2. The entire graph simply levitates 2 units straight up along the y-axis. Easy, right?
Section 5. Now it gets a bit trickier. Horizontal shifts. So moving up and down was perfectly logical. But what happens if a constant sneaks inside the function's brackets? If an external plus 2 moves the graph vertically up in the positive direction, your intuition is probably screaming that a plus 2 inside the brackets, like f of x plus 2, will move everything to the right along the positive x-axis. But let's test that logic. Here is exactly where the math throws us a curveball and where examiners love to catch students out. When the constant is incorporated within the original function, it behaves inversely to what you might expect. If we take a base function, say y equals x squared, and substitute x with x minus 2, we map it onto y equals x minus 2 squared. That minus sign actually shifts the graph in the positive horizontal direction. It moves to the right. So the absolutely crucial takeaway here, and you definitely want to lock this into your memory for the exam, is this counterintuitive rule. A negative value inside the bracket, like x minus 2, shifts the whole graph to the right. Conversely, a positive value inside the bracket, like x plus 3, shifts the graph to the left. Just remember, inside the brackets means horizontal, and it does the exact opposite of the sign.
Finally, Section 6, the translation vector cheat sheet. We've covered the logic, but to seamlessly translate these algebraic rules into something an examiner will instantly award marks for, we use column vectors. Here is your ultimate cheat sheet summarizing how to map functional changes directly into vector notation. Remember, the top number in a column vector is your horizontal x shift, and the bottom number is your vertical y shift. So, an external plus k gives you a vector of 0 over k. An internal minus k gives you a rightward shift, meaning a positive k over 0 in your vector. This table completely demystifies graph translations. Take a mental snapshot of this right now. And that brings us to our final challenge. For the function y equals 2 to the power of x minus 2 plus 2, can you see the shapeshifter at work? You have your base exponential curve, but with a minus 2 inside the exponent and a plus 2 acting externally, where exactly does that invisible asymptote move? Try sketching it out yourself. Mastering how to combine these rules simultaneously is the ultimate cheat code to the coordinate plane. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.